Today's lesson is going to be on the constant of variation. We have two different variations. We have direct variation and inverse variation. So let's just look at some vocabulary here first. We're going to be dealing with x and y in an equation. And when you have x and y in an equation, x is your input, and it is an independent number that you get to choose. So we're going to do some talking about that later on and what you choose. But y is considered your output or your dependent variable, because whatever you pick for x is going to predetermine what your y value is going to be. And you'll see what I mean when we get to the next page and start picking those values of x. If x and y have direct variation, then as x changes, y changes the exact same way. And if x and y have inverse variation, then as x changes, y changes the opposite. Because remember, in math, if you have inverse, that's another fancy word for opposite. So like the inverse of multiplication is division, that kind of thing. So let's just look at some examples of that. We're going to look at direct variation first, and you'll notice that there's this k in here, and that k is your constant of proportionality. Fancy way just to say a number. So all of these tables that we're going to look at, these numbers, the x and y values, are proportional to each other. So we're going to need to know that information in the lessons that are coming up, because the x and y value form a ratio to each other. So that's that proportionality. So really that's just a fancy way, that k of saying it's just a number, but we call it the constant of proportionality. So you can see over here, I've got this y equals kx. Y varies directly with x is what this means. We're going to look at inverse here in a minute. And I just have a couple examples of this y equals kx. So I have y equals x. And remember, when there's no number in front of your variable, there really is. It's just a 1. We don't bother to write it. And then I just have a couple of different options, like y is 2x. The number can also be a negative number, y equals negative 2x. Or that k can also be a fraction. So let's just draw a t-chart and fill it out, and you'll see what I mean when I say x and y are independent variables. So I'm just going to draw myself a t-chart, label one side x, one side y. Now I get to choose my x values. So when I choose an x value, I'm always going to choose an easy number that's nice to work with. I'm not going to choose like 17 1/5, 1,027. Those are all just strange numbers. So I'm going to pick a number that's easy to work with. And I'm actually going to be working with y equals 2x. So I'm just going to pick that one. So I think I'm going to pick 2, 4, 6, 8. Let's just do that. It's always good to pick, a couple of numbers, just so when we get to graphing them, you can see kind of where it's going to go. So since I picked my x value, that becomes my independent variable, because I could have picked anything I wanted. But now my y is going to be a dependent on my x value, because I'm going to take my x value and I'm going to put it down here in my equation. So I have 2 times 2, so that's 4. Now I'm going to put my 4 in. So 2 times 4, that's 8. And I'm going to pick my next one. That's a 6. 2 times 6 is 12. And then my last one is that 8. So 2 times 8 is 16. So you can kind of see that what I mean now when I say dependent. So my y value is directly decided by what I pick as my x value for my equation. So let's just look at what this means going down here. So I did times 2, right? And then this is going to get a little weird, but you'll kind of see what I mean. This, to get from 2 to 6, and we're always talking about multiplication. So to get from 2 to 6, that's actually going to be a times 1.5. Okay? And then to get from 6 to 8, that's actually going to be times 1 and 1/3. So let's see if the y values vary the same way on the other side. So to get from 4 to 8, I had to multiply by 2, so that's working so far. Get from 8 to 12, I had to multiply that by 1.5, so that works, right? Because 8, and then another half of 8 is 4, so that's that half, that's that 12. And then to get from 12 to 16, and multiply it by 1, and 1/3. So that's working straight down that line for me. So x is varying the same way that y is varying, so they have that constant of proportionality. So let's look at the inverse. And I'm again going to just draw myself a t-chart. We'll do some more of these in class. So you can see, let's see, which one am I going to pick? I'm going to pick y equals -2 over x. And we could stick with those, I suppose. Well, let's do 2. Now we can do 4. And I guess we'll just stick with them. That's fine. So I picked my x values, and now I'm going to plug them in to my formula and kind of see what happens. Because again, my x is independent. Now my y is going to depend on what I picked. So I'm going to put 2 in here. Well, -2 divided by 2 is -1, right? Now this is going to be a 4. So I have -2 divided by 4. I'm going to leave it as a fraction. That becomes a -1/2. Hope everybody sees that that's what that means. I'm going to put a 6 in here. So now I have -2 over 6. So if I reduce that -2 over 6 down, this becomes a -1/3. And then if I do this with this 8 in here, so -2 over 8, it becomes a -1/4. So let's look at this. This is times 2. This is times 1.5. And then this is times 1 and 1/3. So let's look over here. To get from -1 to -1/2, I actually had to divide by 2. And if you wanted to take your calculator out, you could see that if I took -2 to get to -1/3, I'd actually have to divide by 1 and 1/2. And then to get from -1/3 down here, I would actually have to divide by 1 and 1/3. So you can see it is the inverse of what happened on the x side. So instead of multiplying by 2, I divided by 2. Instead of multiplying by 1.5, I divided by 1.5. So there's that inverse, right? One side's multiplication, the other side is division. So let's just look at them and do a couple. So we are going to be writing this equation, y equals kx, and we are looking for the k. What happened to my x to turn it into my y? So let's look at this first one over here. It's always a multiplication problem. So what did I do to my x each time? Well, I had to multiply by 4 each time, which makes 4 my k value. So when I write my equation, y equals, the k is what I had to multiply by. So the equation for that particular table and set of values is y equals 4x. So this one has a couple of missing, but I think we can still figure it out. This one's missing a 0 on the end there. I can still figure it out. What did I multiply 15 by to get 30? Well, times 2. And that works right here also, times 2. Which means times 2 is what's happening to my x value. So that means this must be a 10, because 10 times 2 is 20, and this must be a 5. So I'm just filling in blanks by looking at that pattern. So that means my equation is y equals 2x. So let's look at this one down here. Again, a couple of numbers missing, but what did I multiply here? Looks like times 6 and times 6. That means this must be 36, because I have to keep that pattern of times 6, and this must be 72. So 6 is my k value. And that's the equation for that particular table of values. Well, let's look at this one. This one looking a little interesting, right? Since it's getting smaller, that's a division problem, kind of looks like. So I'm going to try an inverse. Oh, I'm going to do it in black. I'm going to try an inverse situation where it's y equals k divided by x. So now I can just put in my x and y values and see what that k turns out to be. So let's just look at this first one. If I had my y value is 1/2 and my x value is 4, well, they're really just equal fractions at this point. So what number does k have to be to make it an equivalent fraction to 1/2? Well, it has to be 2. So let's see if that stays consistent for each one. Whoops, sorry about that. So now I'm looking like I have 1/4 is my y. My x is 8. So what is my k value? Well, 1/4 as an equal fraction with 8 as a denominator is 2/8. So it's looking like my k value is a 2 and that this inverse variation is working for me. So let's just keep going down the line. So I have 1/5. And I know my x is 10. So yep, that would have to be a 2. And just got to try them all. So I have 1/6. And this is a 12. So would my k value have to be a 2? It would. So this particular one is going to be an inverse where my k value is a 2. Nope, let's come to this next one. Just do a couple more. So what did I do here? I'm going to do it in green. So what did I do? I mean, nothing. This is just going to be, that doesn't matter. So this one, what did I do each time? Looks like I multiplied by 6. So because I did times 6, that becomes my k value. So y equals 6x. Here I got a couple of them that are missing. So let's fill in some missing ones. Well, this one's interesting. It looks like a division, doesn't it? Dividing by 2, but this has to be a multiplication problem. So when I multiply, or if I divide by 2, isn't that the same thing as multiplying by 1/2? So if I did that, then this would have to be an 8, and this would have to be a 2. So it's okay to have your values be fractions. And then let's look over here. So this is a times 2, and this is also a times 2. So that makes this 14 and this 11. So 2 becomes my k. And then let's look at this one down here. Looks like times 5 is working all the way down. So 5 now becomes my k value. So in your assignment today, you're going to be looking at tables of values, and deciding what the k value is, or the constant of proportionality that makes that table true. And then that becomes the k value in your equation y equals kx.